Self-referencing tables are ubiquitous in organizational hierarchies, category trees, and transactional chains. Interviewers use this to test if you can join a table to itself and perform correct, name-collision-safe aggregations. In SQL interviews, self-referencing hierarchies are incredibly common, but when you are asked to find managers with at least 5 direct reports, there is an invisible trap waiting for you. If you group by name directly, you might combine different managers and fail the interview. Let's see why. Here is the mistake that fails the interview. You group by the manager's name and filter with having count greater than or equal to 5. It looks simple. But what if 2 managers are named John Smith? Their counts merge, creating a massive false positive in your production data. If Manager John has 3 reports and Manager John has 2 reports, grouping by name combines their counts to 5. The query returns a false manager. In relational databases, names are not unique. We must always group by the unique primary key, which is the employee ID, before retrieving the descriptive name. To solve this cleanly, we perform a self-join. We treat the employee table as 2 instances, E for employees and M for managers. We join them where employee manager ID equals manager ID. We then group by the manager's unique ID and name and filter where the count of employee IDs is at least 5. This keeps every manager separated and completely safe. What about employees who do not report to anyone, like the CEO? Their manager ID is null. By using an inner join on manager ID equals employee ID, those null records are naturally and safely filtered out. If we used an outer join, we would have to filter out the null manager IDs manually. Lock in this mental model. Never aggregate by a text column alone in a relational hierarchy. Always join the tables, group by the unique primary key first, and only then select the descriptive name. This is the blueprint for passing self-referencing SQL interview questions. Let's analyze the subquery with IN approach. Time complexity, ON. Space complexity, ON, requires an inner aggregation followed by a lookup. If not optimized, can trigger an ON squared nested loop in legacy engines. Let's analyze the self-join with group by approach. Time complexity, ON log n. Space complexity, ON. Highly optimized by modern query planners. Performs a hash join and groups by unique keys, achieving ON log n execution. The interviewer will then ask, what happens if 2 managers have the exact same name? If we group by name alone, their reports are combined, creating a false positive. We must group by the unique manager ID to keep their counts separate, then join to get their names. The interviewer will then ask, how would you optimize this query for a table with 100 million rows? I would create an index on the manager ID column. This allows the query engine to perform an index-based grouping, or join-seek, completely avoiding a full table scan. The interviewer will then ask, how would you find managers whose direct reports also manage others? This requires a 3-level self-join, joining the employee table to itself twice to link employees, their direct managers, and their managers.